All right, today, okay, we're going to do this little experiment. We're going to roll a bowling ball down a ramp. Okay, so get out your stopwatches. If you got a stopwatch on your watch, your phone. So it's 1.1 meters long. Okay, measuring this. I'm going to take this bowling ball. You're going to hit start. When I say start, you're going to hit stop when you hear the thud, when it hits the when it hits the table. I just crushed that. I did. Okay. Ready? On your marks, get set, go. Get it? Oh. All right. What you got? Time wise.
2 seconds. 2.3. You are really bad at timing. 1.58.
Okay, I'm gonna round all of our answers.
1.5.
No.
1.8.
I heard 2. I heard 1.5, 1.8. That sounds good. Okay. So, did the ball experience acceleration? How do you know? Okay, sped up, change velocity. There's one definitive thing that would say yes, it totally experienced acceleration because Jacob.
It started not moving and then it decided to move.
Right, it started at rest. Did it stay at rest? No. So was there a change in velocity? Yes. So that has to be an acceleration. Okay. So I want to know how fast the ball was going right here when it hit the table. Can I use this equation to figure out how fast it was going right there at the end? What does this equation technically find? Velocity, what type of velocity? The average velocity. Okay. Have you ever tried to take your average test score and one of those being 0? That'll rock your world. Get a 0 on one test and then you turn around like, oh, I'm gonna study. You ace it. You get 100 on the next. You are still failing the class. Okay, so an average, is this going to tell us actually how fast it's going at the end of the ramp? So do we see a problem? Okay, so this equation falls apart when velocity changes. When acceleration happens, this equation fails. Does that make sense? Okay. So we need a better equation. Okay. So to look at it a different way, let's say I graph the motion of the bowling ball on a position versus time graph. Okay. To use this equation over the 1.8 seconds, that's finding the slope of that line there. That would be my average velocity during that time interval. Does that make sense? But I want to know what's the slope right there. I want to know how fast it's going right at the end. What could I do to be like to make a better approximation? I'm going to tell you. What about going from here to here? Then I could like, that's a whole lot better than that. But is that the actual? I could go from like here to here. Getting better, right? But is that the actual? This is why we need calculus. Calculus scratches that itch. Okay? Meets that need. However, this class does not require calculus. So, what people have done that did know calculus, they figured this out and they came up with some equations known as the kinematic equations. And says, hey, look, if you're experiencing acceleration, you can use these equations and it'll work. Okay? Do not copy these equations down. I'll give them to you on all your worksheets. Okay? You can take a picture if you want, but you'll have access to them anytime you want to. Good with that? Now, this slide can be overwhelming. Is there any variable that you've not been introduced to?
No.
They're all there. They're just in different arrangements, but there's nothing there that's you've not been exposed to. Okay? So, when should you use kinematic equations? So, like when you approach a word problem, there needs to be like this question like, should I go right or should I go left? Like, should I use kinematic equations or should I not? Okay? So, if velocity is changing, you should use kinematic equations. If acceleration is present, you should use kinematic equations. When should you not use this equation? Same thing. Velocity is changing or there's acceleration. Do not use velocity is equal to displacement over time. So is this equation junk? Like, oh, can't ever use that. This is broken. Like, is there an appropriate time when we could use this equation? When is that? Yes. When velocity is constant. Then your average is your actual. On a test scores, if you got a 75, a 75, and a 75, your average is your actual test score. Does that make sense? Okay. So if velocity is constant, yes, please feel free to use that. Good with that? Questions there? All right. Example problem. Here we go. So, child slides down a hill on a toboggan with an acceleration of 1.5 meters per second squared. She starts from rest. How far does she travel in 3 seconds? Okay. The worst thing you can do is to start off going, I wonder what equation I should use. Bad place to start. Okay. The first thing you should do is set up the problem. Draw a picture. That's step one. You don't have to get artistic. There's the girl on the toboggan. And there she is at the bottom. That's it. Okay. Step two is to pick which direction you want to be positive if I don't specify. So make the way that the object is moving, make that the positive direction, your life will be a lot easier. Step 3 is to identify what variables you have. Okay? You've been given some numbers. There's some variables that are associated with them. Here's how you discern what information you've been given. You look at the units. The units are the name tag. Hey, what's up? 10 seconds. Nice to meet you. What measurement am I? Time. Seconds goes with time. Hey, 2 meters per second. Pleasure to meet you. What measurement am I? Velocity. I could be initial, I could be final, but you know I'm on velocity. Does that make sense? So like look at the units. Okay? So meters per second squared. What is this? Acceleration. 3 seconds. What is this? Time. Okay? I've identified all the numbers. Good with that? Now, what am I looking for? How far? My displacement. That's what I'm looking for. Good with that? Okay. Now, is there any other phrases in this problem that could be associated with a number? Like I could define a variable with a number based upon any phrases in here. Quinn. Starts from rest. So your initial velocity is equal to 0. Watch for those. Okay. She came to a screeching halt. The gun went off. And they started like something that's like, oh, something's 0. Does that make sense? Okay. So once you've identified all your variables, now and only now will you say, I wonder what equation I should use. Okay. So let me guide your thought process. You're looking for an equation that has all 4 of these variables. Okay. And only those 4 variables. Thumbs up when you have a guess. For the sake of time, correct answer is the 3rd one. Okay. It has all 4 of these. So you're going to write your original equation before you plug in any numbers. Okay. To show me which one you're going to use. Now you can plug in numbers. Notice that your initial velocity is 0, so that knocks that to 0. Okay. Doing the math, you get that. Before you box your answer, wash your hands of that, and move on to the next question, physics provides you with an amazing opportunity of life experiences. You need to look at that problem, the answer, and say, does this make sense? Does this match my reality? A kid going 7 meters in 3 seconds, is that in the realm of possibilities? Or is that ridiculous? 7 meters, close to like a first down, 3 seconds, sure. If you got 3,000 meters, you'd be like, no, that's ridiculous. You'd break the kid's neck. Does that make sense? Got a worksheet due Tuesday.